Welcome back, Leo Lions. This is Mrs. Morgan with today's lesson on translations. So we're going to get into what we call transformations. Transformations are moving a point or a shape on the coordinate grid in different directions. And we're going to do 4 types of transformations in this bundle. So let's first talk about when we plot points on a graph, we may label them with letters or variables. And we have to know which one was the original point, and then after we move that point or shape, then there's going to also be a new position. So we use different terms to identify which one was the first shape, and then after moving it, which one was the second shape. So the before shape, so the original, is what we call the pre-image. Pre meaning before. So that's your first shape on the graph or point. Then we move it in a certain direction, and then there's a new shape. It's going to be the exact same shape in a translation, but the new shape is what we call the image. And we're going to label them in different ways so that we know which one's the pre-image and then which one after we move it is the image. Okay? Translation. So we're going to talk about 4 different transformations. The definition for a translation is sliding a point or shape, because you may be moving the whole thing. So sliding a point or shape in different directions. So we may plot points on this coordinate grid, make a shape, and we may move it just up. We may move it up and right. We may move it down and left. There's certain different ways we're going to move these points, and then we're going to come up with this new shape. It's just going to be in a different spot on the graph, but it's going to be the exact same shape. So there are rules. Oh, also, I'm going to remind you here, a way to help you remember the difference between all of these, because when we get done, we're going to have 4 transformations. So how do we identify which one's which? To help me remember, I always think of this SL combination here and the SL in a slide. So a translation is a slide, okay? Now, there are rules. What we're going to see is an ordered pair, and this x comma y would be replaced with with numbers on where that would be on the graph. If we want to move the shape up, what we're going to be doing is changing the y value when we go up or down. The reason for that is, think about which one of these axes is your up and down. Well, that's your y-axis. So if we move up, think about positive versus negatives, then the y value is going to increase. So we're going to see a arrow. Now the x is not going to change if we're just moving a shape straight up, but the y value will change, and we will add however many places we are moving. So I'm going to leave kind of an empty space here, because it depends. If I want to move my shape up 3, well, then we'd add 3. If I want to move my shape up 12, well, then we'd add 12. So that blank there changes depending on how many spaces we're moving up or down. Okay, same thing then with the down, but instead of adding, we're going to subtract. So the x coordinate, it stays how it is if we're just moving it down. But then the y value will be minus, and then again, some number, however many places we are moving it up or down, okay? Now, the right versus left, well, that is your x-axis, that is horizontal. So this scenario, our x is going to be changing for the right versus left. So right, again, think of this axis, or that x-axis, where are your positive numbers? It's everything to the right. Negative is to the left. So it's the same thing. If we want to move right on the graph, well, then we're going to add to our x-coordinate. Again, however many places we're moving right. So maybe we move it right 7, then we'd add 7. The y-coordinate does not change if we're just moving it right. Okay, then opposite for left, we would subtract, again, whatever number we are moving, or however many places we're moving it left. Again, y does not change. Now, usually, most often, guys, we are going to be moving it in both directions. So, meaning we will go up and right or up and left. So, usually how you will see this, for our rules, you'll see x comma y, and then we always see this arrow, that is the rule that is happening. So we'll say x plus 2, so that means we are moving right, because remember the x changing, so we'd be moving this shape 2 places to the right, and then let's say y minus 4. So since the y is changing, well, that has to go with down, then we'd go down 4. So this rule that I just wrote, and I just created that off the top of my head, that means we're moving it right 2 and down 4. Okay? Now, what I want you to do, this activity, so we have section 1, section 2, section 3, but there's nothing else there. So I want you to go to Safari and type in Socrative.com, Socrative.com. You're going to hit login, and you're going to do student login. The room name is Morken, M-O-R-K-E-N, and then 178. Hit join. You're going to enter your name. I'm going to put in Morken, and then you're going to get the questions pulled up. So if you want to zoom in, you can. We're going to follow these task cards one step at a time. So on a coordinate graph, we're going to draw a triangle, x, y, z. So x is -5, -3. To help myself out, I'm going to write these down. So x is -5, -3. Y is -5, -1. And then z is -1, -1. And then we're going to plot these 3 points. So be careful with your plotting points. Make sure you go right or left first for your x coordinates. So negative, I'm going to go backwards 5, and then down 3 for the y coordinate. So here is my first point. Remember, if we have multiple points, we always want to label them. So there is x. Y is -5, so back 5, down 1. So there is y. And then z is -1, -1, so back 1, down 1. So there is z. And then I'm going to connect these 3 points to create a triangle. Now, once you do that, then you can answer the questions. Hopefully we can all say, okay, I drew the given figure. And we all get it correct. Okay? What type of figure is this? So we label this, notice there's a triangle, X, Y, Z. So that's how we label it. So is this the pre-image or the image? Remember that from our notes, we said the original position, the first one, is what we call the pre-image. So this is the first shape, that is our pre-image. All right? Now, on the same coordinate grid, we want to graph and label. Notice how we label them now. There's one little apostrophe after the X, the Y, and the Z. So we're going to translate it 6 units to the right and 4 units up. So what we can do, and I'm going to do it in a different color, is move all 3 of these points separately. So let's start with X, and it said 6 units right, 4 units up. So I'm going to take this X point and move it 1, 2, 3, 4, 5, 6. Just simply count 6 to the right, and then up 1, 2, 3, 4. So here is my new point X. But instead of labeling it just X, because we already have a point X, I'm going to put apostrophe there. Now it's a new point for X. And we're going to do this for all 3 of those points. So I'm going to go to Y and go 1, 2, 3, 4, 5, 6 to the right, up 1, 2, 3, 4. Here's my new point for Y, so I put Y apostrophe. And Z, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4. There is Z, and I'm going to draw that triangle as well. So again, once you do that, I translated the figure. Now, what type of figure is this? And notice how it's labeled triangle X apostrophe, triangle Y apostrophe. So this is the new shape. This is what we call the image. Okay, now you want to look at where is X prime, and we actually call that, with that little apostrophe, we call it X prime. So we're looking at X prime. Which quadrant is it located in? If we forget our quadrants, remember, quadrant 1 starts in the upper right-hand corner. It's all positive numbers. And then this is quadrant 2, quadrant 3, and most often we label quadrants with Roman numerals, quadrant 4. So X prime is in quadrant 1. Where is Y prime? It is also in quadrant 1. Notice X prime, Y prime, Z prime, they are all in quadrant 1. So quadrant 1, and Z prime is also in quadrant 1. Okay, notice I am on now 8 of 25. So let's think about this. We're going to choose all that apply here, all the true statements. So X, Y, and then X prime, Y prime are congruent. So look at X, Y. So we're looking now at line segments. So X is here to Y, this line segment. Is it identical to X prime to Y prime? They're both 2, they are congruent. Notice our shape did not change at all. It's the exact same shape. So all of the angles are the same, all of the side lengths are the same, the perimeter, the area, none of that changed. They're congruent. But be careful with how they are worded, because if we go over to B, it says YZ. So now we're looking at Y to Z, so YZ, and it says, is that congruent to X prime, Z prime? So X prime is here, and then Z prime is here. Is that the same as YZ? Those are not the same, so B is false. So notice how they are worded. Now, angle X, so that little kind of looks like a less than sign. Angle X is congruent to angle Z, angle Z prime. Those are different letters, so they're not congruent. But in D, angle Y is congruent to angle Y prime. Those are going to be the exact same, okay? Here, E is saying triangle XYZ. Is it congruent to triangle X prime, Y prime, Z prime? We already talked about that. They're the exact same shape. We didn't change the shape. We just slid it over, okay? Now, similar, in F, it says that triangle XYZ and triangle X prime, Y prime, Z prime, they're similar. Similar meaning they're the same shape, but they're a different size. Well, these are the exact same size, so F is false, all right? G says that this transformation is a result of a rigid. Rigid meaning it's not changing the shape. It's not going to change any of the things. So that is very rigid. There we go. I submitted it. They're all correct. All right. Now, I want to go back to our notes, and I want to write, like I did in purple here, I want to write an actual rule for the translation that we just did. So the rule for this problem, we started with X comma Y, an ordered pair. And remember, this is how it always looks. Then it has an arrow. Now, we moved right 6. So up here, we have our rules. Moving right means we're going to do something to our X coordinate, and we're going to add. So we're going to say X plus 6, because we went 6 to the right. And then comma, what did we do with the Y? We went up. So again, look at our rules up here. So up means we're going to change our Y coordinate, and we're going to put it as Y plus, and however many we went up, and we went up 4. So Y plus 4. So here is what our rule looks like. There are times that I will just give you this rule and not tell you that we're moving right 6 and up 4, but you'd have to use the rule to determine where we're going, okay? Or you could take the ordered pairs, like up here, and do -5 plus 6. So we would get 1. And then -3 plus 4, we'd get 1. Notice 1 comma 1 is x prime. So this is x prime. And we could do that with all of these. So plus 6, we'd get 1. Plus 4, we'd get 3. And this should be then y prime. And let's double check. 1 comma 3, that's right. And then last one, we do plus 6 plus 4. So we can apply that rule even if we don't have a graph. And we could figure out what those new coordinates would be. So plus 6 plus 4, we'd get 5 comma 3. And that should be z prime, which it is. Okay, so I did that first section with you. Now I want you guys to take off and try the next 2 examples on your own, and you can follow along with that Socrative, those slides. It tells you now we're going to graph a quadrilateral, and as you go through, you can submit your answers and see if you have these